It was a strange experience, walking into the store to see empty shelves. So you probably remember 4 years ago, panic buying took over, and our supply chains just could not catch up with the increased demand. It wasn't just a minor inconvenience. It was a clear sign of how important responsive and efficient supply chains are to our lives, because when they fail, they impact all of us. But supply chain disruptions happen very often. This is not the first time. And each time those disruptions happen, there are journal articles, there are newspaper articles talking about different ways of preventing this from happening the next time. And most of the time, they mention the use of information technologies, the use of artificial intelligence to make this process a bit more efficient. But here's the thing. When that pandemic happened, there were already AI solutions for supply chain management. So my question is, what went wrong with those AI implementations in supply chain management? What was the problem so that we experienced that stock-out issues in the stores? To answer that question, I interviewed 20 supply chain managers. I asked them how they use the AI tools in their workplace to learn whether they relied on these tools or what made them just ignore those tools. Turns out that those people used those AI tools, but they ignored and they didn't listen to their recommendation. So they didn't like the recommendation given by AI. They didn't understand why it was acting that way, or they just felt that they knew more than the system. And their solution was to constantly ignore and override the AI recommendations, basically doing the task manually. This system is really expensive to implement. These systems are difficult to implement. So this is not an ideal solution. This is not an ideal situation. So it seems that it's clear that we need to find ways to make these experts understand AI and use them more as planned. And if you were wondering whether those experts initially gave an AI a chance, the answer is yes. They initially trusted the AI, they tried to use it, but it took them only one failure on the AI side to just continually ignore the AI recommendations afterward. So it seems that the problem is understanding the long-term use of and reliance on AI rather than the initial adoption on AI. And looking back at the interviews, it was clear that those experts were repeatedly reporting their lack of control over the algorithm, their lack of configuration abilities on the software, and they were mentioning this as one of the reasons they were ignoring these systems. So we wanted to test and we wanted to validate whether users' perceived control over AI is really an impacting factor in their reliance on AI. We designed an experiment and we designed a game for this experiment. In this game, our participants came into a lab for 2 hours and they played the role of a demand forecaster for a virtual ice cream company that we invented. They were using real-life software such as SAP, so it was realistic for them to just get into this role for 2 hours. And all they had to do was to take a look at the chart, which had the last 20 weeks demand, and they just need to predict the upcoming weeks in this simulation in terms of the required ice cream quantity. And they did this task for 75 times in our experiment. So they used this AI system for a long time. In 2 hours, they repeatedly interacted with this system. And in each of these trials, they initially saw an AI recommendation for the upcoming week's demand for ice cream, and then they had 2 chances. Accept AI recommendation or just input your own number. And to test this perceived sense of control, we divided the participants into 2 groups. The first group, they had access to an AI configuration screen. So this AI configuration screen had 3 parameters, basically asking them what they felt about the current situation in the ice cream market. whether it's seasonality, whether it's trend. And each time of these 75 trials, the system initially asked them to provide their opinion on the market. And the other group didn't see this screen at all. And this difference in their interaction with the system caused a difference in their perceived sense of control in the decision-making process. And all while they were doing these tasks, playing this game for 75 times, we captured their eye movements on the screen, and also we captured their electrical brain activity to understand their decision-making process, to understand whether they were engaging with the task to try to do it manually, or whether they were relying on AI to just benefit from its advances. I have 3 analyses to present to you. The first one is about their trust and reliance in AI. So in each of these trials, they saw a number presented by the AI, and then they submitted maybe another number or the same number in the end of the trial. And the difference between these 2 numbers, we use this difference as the measure of how well they relied on AI. If this number is large, this means that they relied less on AI. If this number is small, they relied more. And our analysis shows that people who had access to this configuration screen applied less overrides. In other words, participants with no AI configuration access applied 12% larger unnecessary overrides to the decision. Now, the 12% number might seem maybe small to you, but imagine a large organization, thousands of locations, hundreds of trucks each day moving to different locations. This 12% might be the difference between losing money or making profit. The second analysis is about their cognitive engagement with the task. Remember how they were trying to do the task manually, those experts that I interviewed with. So in this analysis, I wanted to see whether the participants are acting differently in terms of trying to do the task manually or relying on AI. We use their eye movements on the screen and their brain signals to understand whether they exerted more cognitive effort to do the task manually. And the results show that participants with no access to this AI configuration screen exerted more higher cognitive effort to do the same task. And in the end, their performance was not better than the other people who just relied on AI and did not overwork themselves. This is important because it seems that these people who had no access to an AI configuration made them overwork and tired, and when an exception happens, those people see those exceptions with low energy. And the last analysis is about the evolution of user trust in AI over time. Remember, I was talking about those interviews and how experts lose their trust immediately when an error happens, and it was difficult for AI to just gain that trust from human again in a long term. So in this analysis, I wanted to see whether this perceived sense of control changes how fast they are regaining their trust in the AI. To test this, we programmed some errors in the game. So in 15 of these 75 trials, our AI recommendation system provided an obviously incorrect recommendation. And in the end of each trial, we asked our participants to rate their sense of trust in the AI on a scale of 1 to 7. And you can imagine, after an erroneous recommendation, their trust drops to 1, 2. And then our question was, how fast do they recover to their baseline level? And is it different across these 2 groups with control, without control? And the results show that participants who had access to this configurable AI interface are 18% more likely to regain their trust in AI. This means, maybe I can put it in another way, this can be a difference of doing a task manually for 4 days versus doing a task manually for 5 days. So to conclude, users' perceived control of AI matters in nurturing their trust in AI. And I have recommendations for 3 groups of people. If you're a designer of these systems, or if you are purchasing such a system for your team to use, demand user involvement in the design of these systems and in the implementation of these systems. Design these AIs to increase user involvement in the decision-making process. And if you are training new employees to use such AI decision-making tools, train them to experiment with the tools. Train them not to blindly start to use these systems because they sound fancy. They first need to experiment with it, see its boundaries. And the same goes for the users of such tools. In the beginning, do not start fast. Start slowly, take it slowly, explore its limits first. See when it fails, how it fails, try to understand it. Try to see what you can configure in the configuration and try to understand what type of behavior changes you observe when you configure it differently, so that you are not surprised when it fails. Thank you.